So a few weeks ago, my sister calls me and says, "We're counting plankton today." I had never counted plankton before, but it sounds interesting. It also strikes me as the worst kind of excuse to hear if someone doesn't want to go on a date with you. I have to count plankton that day. Otherwise, I'd be right there. She said, I got to do a plankton count. I want you to help me with the plankton count. And she had told me something about how she was monitoring plankton on the island that I live in, on Orcas Island, which is in the extreme northwest, just south of Canada, next to the Pacific Ocean. A lot of plankton there, apparently. Needs to be counted. So she comes over, and I start learning about it, and I start seeing all these parallels with testing, and I want to share that with you. So first, let's turn this on. Maybe that will. Okay, so this is the equipment. All right, this is a knee pad, which promptly was blown by the wind into the ocean, and we didn't see it for a while. Here's a bucket. I didn't see her use this for anything. I don't know what that's for. A temperature, infrared temperature gauge to measure the temperature of the water, a sample flask. This is a special net to capture the plankton in this little cup thing there. And so there she is. She always stands in the same place because she wants repeatability for some reason. And she dips the thing all the way down and pulls it up, and then all the plankton gets filtered down into this little cup, and it's supposed to give a nice concentrated sample of plankton, which looks like this. Okay, and so you see the plankton even with the naked eye, even with my megapixel camera. I can see there's something interesting going on there. Well, so we've got to count this plankton, but we don't really count it, though. It turns out that we count a few drops of it, and we don't really count it. We assess it. It turns out you don't actually count 1, 2, 3 because there's a lot of plankton, even in a few drops. So here I am. I'm ready to assess the plankton. I got my materials. I got my microscope. I'm all set to go. All right. And she just put me right there in the microscope and said, "Okay, identify all the plankton." And here's what we get to work with. We've got all these little most wanted posters. Here's a hemialis, a leptosyndricus, all that stuff. I got all this bacteria there. I'm ready to go. And then there's also the common phytoplankton key, because we're just counting phytoplankton, not zooplankton. I know what you're thinking. Zooplankton, you're probably talking about zooplankton. Heard it before. No, phytoplankton. That's the plant stuff. Zooplankton they move fast, and they're big, and they're like worms and stuff. These are tiny little creatures with chloroplasts. They move around, though, almost like they're animals, and some of them move pretty quickly. So I have my key, my phytoplankton key. I've got my pictures. And not only that, I'm all set to go, but I got this, too, my secret weapon, a taxonomic guide to some common marine phytoplankton by none other than Rita Horner. Yes, that Rita Horner, the one who wrote that book about the phytoplankton. She is kind of our Yoda. I haven't actually spoken to her yet, but I've heard that she's very smart about this. Notice it says some. That's going to turn out to be important. It says some. All right, you would think, why doesn't she just write the book of all? Well, it turns out that's a little hard to do. So here's what I see through the microscope. Where's the phytoplankton? I mean, is that little thing what I'm supposed to count? Or what's that? Is that just like a little piece of grit or something? Is that a thing on the slide? Is that a piece of something? Is that even alive? I don't know. This looks to me like something that died and is just kind of rotting. But it turns out this might be something. I only know now because I was reviewing the materials today. This is what I see in the slide. I got 40 screens of this that I have to go through, 40 of them. And I'm supposed to assess all the plankton. And my sister's like, "Well, okay, so what do you see?" It took us 20 minutes to figure out what these things were, because they all look a little different, but it turns out every one of these things is actually the same thing in different stages of its life, and there's little fragments of it around. And you might think, "Oh, this is a fragment of something." That's an entire creature. That's not a fragment of a creature, it turns out. And that looks like a little stain. That's another creature. And then there's things called picoplankton that are really, really small. So some of these things might be picoplankton. It's kind of amazingly hard, turns out. Let's check this out. You see these guys? I didn't count them because I thought they were bits of dead fish. But after about 30 minutes, I looked at the sample again, and I noticed one of these things moving a little bit, just really slowly, but it's moving. It's alive. It's a living creature, probably saying, kill me, but it's a real living creature, and it's not in any of my keys. I don't know what it is. Is it an amoeba? Is it a zooplankton? I don't know what it is. Here's a bunch of different, what are called ditylems. And the ditylems are constantly dividing. So you see these hourglass shapes sometimes, and when it's finished dividing, they're in two little separate units right there. And then early in its life, it's one big blob like that. And so they all look different, but you quickly realize, oh, they're all the same basic thing, ditylum. This is a bloom. It's called a bloom of ditylum. The ditylum is dominant. It's going nuts. This little wine glass thing, I have no idea what it is. Can't find it anywhere. This bomb-shaped thing moves really fast. I don't know if it's animal or vegetable. Don't know what it is. It's not in any of our keys. This is a thalassonema. You got that. That's an easy one. This seems to be a worm larvae, but it doesn't show up exactly in any of our keys. We're pretty sure it's a worm larvae. It was moving really fast, and it's much bigger than anything else. That's a eucampia, that's a gyrosigma, that's a catoceros. I just like saying that, catoceros. It sounds like some kind of dinosaur. Looks like a millipede. We don't know what that is, but I'm thinking it might be a piece of a catoceros. I can't really tell. That's one of the problems, is just like in testing, if you are new to testing, really new to testing, and someone says, look at this screen and tell me if you see any bugs, you're going to have a lot of struggle with that. Like, well, there's a million pixels on the screen, and is that line supposed to be there? Is it in the right place? And you've got to learn how to tell the different objects from each other, which is basic technical knowledge. But then, of course, technical knowledge gets more and more complex. There's more and more things that you learn about that. So I missed at the very beginning of figuring out what's the difference between a piece of grit and an actual phytoplankton that I'm supposed to be counting. And it's an interesting experience to go from being an expert software tester where I look at stuff and I automatically ignore the things that don't matter, back to being a novice again, and you remember how hard it is to learn what matters and what doesn't matter. It's important, I think, to put ourselves in a novice's shoes at times, and this is one way that we can do it. We don't know what that is. Can't find it anywhere. We've tried Googling for it. Looks like some kind of alien. This, we didn't know what it was at first. Triangle-shaped UFO. But then I was reading an article about ditylum, and it turns out that a ditylum, when you look at it edge on, down the center of it, it's triangular. So this is probably a ditylum that I'm seeing from the edge. And then we don't know what this is, but it seems to have two little strands coming off it, flagella. And then I found this picture. Well, is this the same thing? I don't know. This thing's supposed to have little fur on it. I can't even tell. It just looks like a blob, cornflake blob, but it's got these two little legs coming out of it. It's the only thing that, somewhere I have it. Here it is. Okay. They give you a little manual. The manual is almost useless. It's just got a bunch of little things. It's almost like random stuff that they copied. This one is a page. I don't know where it comes from. But after all, you get these beautiful color pictures. And then you get just this thing here. Like, oh, yeah, that too. Well, which of it is this? They all look the same. One is just like a strawberry-shaped blob. And the other is a potato-shaped blob. And this is kind of a shiitake mushroom-shaped blob. Am I supposed to tell whether it's a chlorophysae or a eustigmatophysae? I'm pretty sure it's a eustigmatophysae, but don't hold me to that. And then what's with this catoceros? It's being under attack by some kind of, we figured out these are probably navicula. So this navicula, they're like pirates or something that are attacking this thing, tearing it to pieces. So we sent this picture to Rita Horner, and she said, no need to worry about the catoceros. And then it made me You know, there's something very strange about that. We take his sample from the sea, and now there are thousands upon thousands, hundreds of thousands of little plankton, all of which are going to die because we've just taken them from the sea, right? So I'm wondering, is she actually worried about whether the welfare of these little creatures? The pennate diatom, she's not even sure which. She's the one who wrote the book, and she didn't say like, oh, that's obviously an avicula. Didn't you know? No, it's just some kind of thing, a mysterious alien creature from planet we not know what. And apparently it's an epiphyte, and she's pretty confident that these things aren't doing any damage to that, but I don't know, if I was this Cattosaurus, I'd be pretty annoyed at this point. So, here's what I learned. Assessing plankton is really hard. It's very expensive to automate. They actually have these capsules that automate this, sort of. They're very expensive, and they take the sample, and then they boil it or something, and all the DNA comes out, and then they do this DNA thing, and they can look for certain species. So it's not a comprehensive look at all the species like a human can do. Like I said, there's about 40 screens, and I immediately thought, well, isn't there a microscope that I can press a button and it'll just take a mosaic of the 40 screens and put it on Photoshop, and I can look through that instead of physically moving the thing around? Turns out those exist, but they're very expensive. So I got to do it by hand. And I bring my camera up and take pictures by hand. The identification keys usually don't work. I can identify like 20% of all the things that I see, if that. And only 2 days of training, and I'm not even one of those guys who got the 2 days. I didn't even get that luxurious, at a Plankton dojo level of mentoring. My sister got the 2 days, and she has no idea what this stuff is either. We're both completely clueless. Several hours it took me. And still, I found I was missing stuff. Still, hours later, I'm looking through even now as I was preparing this talk, I found, oh, there's a protoparadinium. It was there all along. And I somehow skipped over it because the Cattosaurus is so photogenic. So inattentional blindness is a real problem. Just like for testers, our observation mechanisms are specific to the kinds of things we are observing, and the more expertise you have in observing a particular kind of thing, the less you will be liable to miss something very important. But still, as you try to manage your attention, what we found is we would frequently chase a little guy that was running all around, and we'd chase it around, and I'd lose my place. I'd be on like the 10th screen that I was supposed to look at, and then this thing would start wiggling, and then I'd forget, and then I'd kind of try to find where I was again. So what I'm worried about is the sampling's inconsistent. There's a big rip in her net. She doesn't care. The training is inconsistent. The people are inconsistent. I felt like I am going to bring this into Photoshop, and I am going to count everything. It took me hours. And, oh, it's all moving, by the way. There's a protoparadinium. It's just like, they're like little terrible jumping beans that just roll around. And then this is a pseudonychia, which is one of the key things we're looking for. It's toxic, and it moves around back and forth. And a lot of these things just kind of roll around. So while everything's moving, I'm also supposed to be cataloging everything. And then it occurred to me, this is just like crowdsourced testing. It's just like beta testing. And that's kind of the key to understanding this. They give us checklists. That helps. Just like in real life with our guide word heuristics and lists of, if you see this kind of bug or that kind of bug, make sure you tell us. This is exactly what I do with crowdsourced testers. It's exactly what I do with novice testers. If I want them to help me quickly, I'll say, if you see anything like this, this, or this, that's really important. Make sure you tell me about that. And anything else that you think is strange, tell me about that too, like if a Cattosaurus is getting attacked by an avicula. One thing that I found really interesting is that when I first was doing this, the first 10 minutes, I felt like Cattosaurus, what is a catastrophe again? Oh, it's the millipede thing. Yeah, okay. Catastrophe. Catoceros. No, it's catastrophe. What's this? Diddlum? Ditilum? What's that again? They would go out of my head. But after about 45 minutes, the word starts sticking. And then I start feeling like a professional biologist. Then I'm just talking about, like, well, that's an Alexandrium. And, that's got to be a gyrosigma. But not a pleurosigma, of course. So at first, like the first few minutes, you feel like I'm never going to learn this. A couple hours into it, you start feeling like I want to learn all of it. This is actually, it's quite addictive because part of what you're doing is it's like digging for treasure, like you're trying to find rubies in a ruby mine or something. You're thinking, oh, I could be the one to find the first instance of a pseudo-Nietzsche suplex in the Great Northwest. My name will go down in history. We actually don't give counts, but we do give abundance levels. If it's present, then we just get a check mark. If it's common, then we say C. And if it's a bloom or abundant, then we say B. So that makes it a little easier too. But the question still remains, why trust the volunteers? How can the scientists use our data? We turn in these sheets. I found out the answer to this. They totally ignore our sheets. That's the answer. They totally ignore them. Under normal circumstances, the scientists completely ignore what we do. It turns out. Okay. So why do we do this then? Because the volunteer network, just like beta testing, is there to provide early warning for a big event. If pseudo-Nietzsche shows up in the water, if protoparadinium, if Alexandrium, any of these little guys show up, the wrong kind of thing comes up, then we have to shut down the fisheries. We have to shut down the clam fisheries on the island. And the scientists make that call. So what the volunteers do is if there was a bloom of the bad stuff, it would be really easy for even the most rank amateur like me to see it. It would be trivial for us to see it. Just like if you were having something that crashes on login, I mean, you don't need to be a super professional tester, to say, that's iocane. Stake my life on it. You don't need to. You don't need any advanced theory of testing to find many kinds of really, really bad bugs, and just the same with these bugs. So the scientists use the very inexpensive volunteers, some of whom take a few minutes to do what I took hours to do because they're ignoring most of it. They just look for the 4 bad kinds of phytoplankton, and if they don't see it in any kind of abundance, then they say, we're done. I have protected the fisheries today. But someone like me, I am motivated differently. I'm not interested in protecting the fisheries. That's not why I do it. I'm interested in whether I can make a rare find, which strikes me as exactly why I became a tester, why I love being a tester, for that rare bug that I can wear like a medal. I found the superbug. I did it. And I get my superbug medal. That's what motivates a lot of testers. Not just like, oh yeah, I guess we can release the product. Maybe some testers are motivated that way, but I haven't met many. Most testers, if you ask them, will say, I likes to break stuff. They're looking for the big bug. And if they don't find it, they're a little bit depressed. Even though I guess it's good for the project and all. And I felt that same way about the plankton. Yeah, I didn't find very many Alexandriums. Apparently, it's no danger to the fisheries this week. But that's really not what I'm into. Now I have this feeling, and here's what I want to do. And I'm making a proposal about this. I want to create a better encyclopedia of all the phytoplankton with much better pictures than they gave me. Why isn't somebody doing that? I think it's because these scientists don't have Photoshop. I think they just don't have the equipment or they don't have the time or something. That's why they make books that say some of the phytoplankton. So my sister and I were going to start working on this. That's my presentation. Thank you very much.